Chapter 4. Integers. Introduction of integers. We know that on adding two whole numbers, we always get a whole number. In case of subtraction, we may or may not get a whole number. Consider the following examples. 12 minus 7 is equal to 5. 23 minus 10 is equal to 13. 37 minus 21 is equal to 16. But what happens if larger number is subtracted from a smaller number? 7 minus 12 is equal to 10 minus 23 is equal to 21 minus 37 is equal to. The result of these are neither a natural number nor a whole number. Thus, system of whole numbers is not enough for such operation. We need a type of number system to represent or interpret the above differences. We have natural numbers 1, 2, 3, 4, 5, 6, 7 and so on. We introduce new numbers as minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 and so on, read as minus 1, minus 2, minus 3, minus 4 and so on. Let us see that 1 plus minus 1 is equal to 0. 2 plus minus 2 is equal to 0. 3 plus minus 3 is equal to 0. 4 plus minus 4 is equal to 0. Thus we observe that minus 1, minus 2, minus 3, minus 4 and so on are opposite of 1, 2, 3, 4 and so on. We rewrite the numbers 1 minus 1, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5, 6 minus 6 and so on, or minus 6 minus 5 minus 4 minus 3 minus 2 minus 1, 0, 1, 2, 3, 4, 5, 6 and so on. These numbers are called integers. In our daily life, we come across the terms profit and loss, height of a place above sea level, temperature above and below 0 degrees Celsius, etc. The idea of oppositeness can be represented by symbols plus and minus. The profit of rupees 175 means plus 175. The loss of rupees 175 means minus 175. Plus 15 degrees Celsius means above 0 degrees Celsius. And minus 15 degrees Celsius means below 0 degrees Celsius. So, when natural numbers are assigned plus or minus sign, they become integers. Therefore, we arrive at the following definition. The collection of negative numbers, positive numbers, and 0 together are called integers. Positive integers, the numbers plus 1, plus 2, plus 3, plus 4, plus 5, plus 6 can be written as 1, 2, 3, 4, 5, 6. The positive sign is omitted and understood. These are called positive integers. Negative integers, the numbers minus 1, minus 2, minus 3, minus 4, minus 5, minus 6 are called negative integers. Representation of integers on the number line. We draw a line and fix a point almost in the middle of it and call it 0. We mark equal distances on the right-hand side as well as on the left-hand side of the 0. On the right-hand side, we mark the points of division as plus 1, plus 2, plus 3, plus 4 and so on. And on the left-hand side, we label the points as minus 1, minus 2, minus 3. 1 and minus 1 are at equal distances from 0, but in opposite directions. 2 and minus 2 are at equal distances from 0, but in opposite directions, and so on. Ordering of integers. In the representation of whole numbers on the number line, we find that every whole number on the right of the number is greater than every whole number to its left. We follow the same convention in case of integers. 3 greater than 2 since 3 is to the right of 2. 2 greater than 1 since 2 is to the right of 1. 1 greater than 0, since 1 is to the right of 0. 0 greater than -1, since 0 is to the right of -1. -1 greater than -2, since -1 is to the right of -2. So, 2 greater than 1, -2 less than -1. 3 greater than 2, -3 less than -2. 4 greater than 3, -4 less than -3. Therefore, if a and b are two integers such that a greater than b, then -a less than -b.
Absolute value of an integer. The absolute value of an integer is its numerical value, irrespective of its sign. We use two vertical lines on either sides of the integer to show its absolute value. Thus, mod of -5 is equal to 5. Mod of +5 is equal to 5. Mod of -13 is equal to 13. Mod of +13 is equal to 13. Note that mod of 0 is equals to 0. Mod of -14 is equal to 14. But minus mod of 14 is equal to -14. Thus, for every integer a, mod a is equal to a if a is positive or 0, minus a if a is negative. Following examples will make these concepts more clear.
Example: using the number line, write the integer which is 3 more than 4. Solution: we start from 4 and move 3 steps to the right to obtain 7. Hence, 3 more than 4 is 7. 2 more than 0. We start from 0 and proceed 2 steps to the right to obtain 2. So, 2 more than 0 is equal to 2. Example: write opposite of each of the following. 40 kilometers north. Solution: 40 kilometers south. 115 meters above sea level. Solution: 115 meters below sea level. Example: write 4 negative integers less than -20. Solution: consider the number line. As we move from left to right, numbers go on increasing. -20 plus 1 is equal to -19. -19 plus 1 is equal to -18. -18 plus 1 is equal to -17. -17 plus 1 is equal to -16. Hence, the required 4 numbers are -19, -18, -17 and -16. Addition of integers. We know that whole number is either positive integers or 0. We can add the integers in case they are positive. But if one of them is negative or both of them are negative, we follow certain rules as given below. Rule 1. To add two positive integers, find the sum of their absolute values and place a positive sign before it. Example: find the value of +12 plus 6. Solution: sum of absolute values is equal to
Mod of
+12 plus
mod of
+6, which is equal to 12 plus 6, which is equal to 18. Rule 2. To add two negative integers, find the sum of their absolute values and place a negative sign before it. Example: evaluate -16 plus -13. Solution: sum of absolute values is equal to
mod of
-16 plus
mod of
-13, which is equal to 16 plus 13, which is equal to 29. Placing negative sign before sum, -16 plus -13 is equal to -29. Addition of integers on the number line. We have learnt to represent integers on the number line. To review, +5 represents a moving of 5 units towards the right of 0, and -5 represents moving of 5 units to the left of 0. Example, represent plus 3 plus 4 on the number line. Solution. We start from 0 and move 3 units to the right. Then we further move from this position to 4 units towards right and reach at 7. We have plus 3 plus 4, which is equal to plus 7. That is 3 plus 4, which is equal to 7. Properties of addition of integers. All whole numbers are integers. Therefore, all properties of operations on whole numbers are also true for integers. There may be additional properties. Closure property. If a and b are two integers, then a plus b is also an integer. That is, sum of two integers is always an integer. Let us take pairs of integers and observe their addition. 2, 3. 2 plus 3 is equal to 5. 5 is an integer. Minus 3 plus minus 5 is equal to minus 8. Minus 8 is an integer. 7 plus minus 3 is equal to 4. 4 is an integer. 4 plus minus 9 is equal to minus 5. Minus 5 is an integer. Commutative law of addition. If a and b are two integers, then a plus b is equal to b plus a. Let us take integers minus 5 and 12. Minus 5 plus 12 is equal to 7. 12 plus minus 5 is equal to 7. This implies minus 5 plus 12 is equal to 12 plus minus 5. That is, change of order of addition makes no difference. Associative law of addition. If a, b, c are three integers, then a plus b plus c is equal to a plus b plus c. Let us take integers minus 6, 4, minus 9. Minus 6 plus 4 plus minus 9 is equal to minus 2 plus minus 9, which is equal to minus 11. Minus 6 plus 4 plus minus 9 is equal to minus 6 plus minus 5, which is equal to minus 11. Hence, minus 6 plus 4 plus minus 9 is equal to minus 6 plus 4 plus minus 9. Existence of additive identity. If a is an integer, then a plus 0 is equal to 0 plus a, which is equal to a. 7 is an integer, so 7 plus 0 is equal to 0 plus 7, which is equal to 7. Similarly, minus 4 plus 0 is equal to 0 plus minus 4, which is equal to minus 4. The integer 0 is called the additive identity. Existence of additive inverse. For every integer a, there exists its opposite, minus a, such that a plus minus a is equal to 0, which is equal to minus a plus a. We have minus 11 plus 11 is equal to 0. 6 plus minus 6 is equal to 0. Remark: the additive inverse of 0 is 0. Existence of successor and predecessor. In whole numbers, 0 is not the successor of any whole number, whereas 1 is the successor of 0, 2 is the successor of 1, 3 is of 2, and so on. The number 0 has no predecessor in whole numbers. Every integer has a successor and predecessor. For every integer a, there is a predecessor a minus 1 and successor a plus 1. For example, 3 is a successor of 2, 0 is a successor of minus 1 and predecessor of 1. Subtraction of integers. We know that subtraction is an inverse process of addition. For subtracting integer b from integer a means adding negative of b to integer a, that is, a minus b is equal to a plus minus b, that is, adding additive inverse of b to a. For example, to subtract 3 from 7 means finding a number which when added to 3 gives 7. Obviously, the number is 4. Rule: to subtract one integer from another, we find the additive inverse of the integer to be subtracted and add to the other integer. Example: subtract 9 from 5. Solution: 5 minus 9 is equal to 5 plus minus 9. The additive inverse of 9 is minus 9, which is equal to minus 4. Example 2. Subtract minus 365 from 0. Solution: 0 minus 365 is equal to 0 plus 365, which is equal to 365. Minus 1346 minus 475 is equal to minus 1346 plus 475, which is equal to minus 871. Properties of subtraction of integers. If a and b are two integers, then a minus b is also an integer. For example, 6 minus 4 is equal to 6 plus minus 4, which is equal to 2, which is an integer. Minus 7 minus 6 is equal to minus 7 plus 6, which is equal to minus 1, which is an integer. Subtraction of integers is not commutative. If a and b are two integers, then a minus b not equal to b minus a. For example, 9 minus 3 not equal to 3 minus 9. Minus 6 minus 5 not equal to minus 5 minus 6. For any integer a, 0 is the identity for subtraction. A minus 0 is equal to a. 0 minus a not equal to a. For example, 7 minus 0 is equal to 7. 6 minus 0 is equal to 6. Subtraction of integers on the number line. We have learnt that the positive and negative integers are opposite numbers, one to the right of 0 and the other to the left of 0 on the number line. To review, in order to subtract 5 from 9 is the same as finding a number which is added to 5 to get 9. In case of subtracting minus 5 from 9, we have to find a number which when added to minus 5 gives 9. Obviously, such number is 14. We now represent this on the number line. To subtract minus 5 from 9, that is 9 minus 5. When we subtract a negative integer, we get a greater integer. So, we move to right to 9. Consider it in another way. We know that additive inverse of minus 5 is 5. Thus, adding the additive inverse of minus 5 to 9 is the same as subtracting minus 5 from 9. We write 9 minus 5 is equal to 9 plus 5.